Alright, so in our next section, we're going to be starting to look at polygons and how we can figure out their angle sums. So first, let's talk about some vocabulary. A polygon comes from the Greek word poly and gon. Poly means many, gon meaning angled. So really and truly, it means many angled. But it's a closed plane figure with at least 3 sides, and those sides must intersect only at their endpoints. And then we've also got vertex, which we're familiar with from our triangles, but know that polygons also have vertices as well, and this is the point where the 2 sides of the polygon are meeting. So when we name a polygon, just like when we name a triangle, we have a certain mechanism that we have to use. First of all, you have to use all the vertices. So if there are 10 vertices, then you have to use all 10 of them. Second thing that we have to keep in mind is that they have to be in consecutive order. So what's consecutive order mean?
Yeah, like one right after another.
Good, one right after the other, okay? I can't just jump around, okay? Now, we can start with any vertex that we want to, and we can either go clockwise or counterclockwise. But you can't just jump around and randomly pick them. You start with one and you go in order around the figure, okay? So, let's see. Lucas, pick a vertex. H, okay? Blake, clockwise or counterclockwise?
Clockwise.
Clockwise. So if I'm starting at H and I want to go clockwise, then what would have to come next? K, and then L, P, R, and D. Good. So that's one way that we can name this figure. Okay? Alright, so this time let's start with P and let's go counterclockwise. So if I go P, then what would have to come next? R. Oh, wait a minute. If we go counterclockwise, not R. L would have to go next. K, H, D, and R. Good. Okay? So you have to use all the vertices. Doesn't matter which one you start with, but they have to go in order as they appear around the figure, either clockwise or counterclockwise. So one way that we can classify polygons is either by saying that they are convex or that they are concave. Okay? Alright, so convex has no diagonals that has points outside of the polygon. So a diagonal is connecting 2 vertices that are not already connected with the side. So for instance, L is already connected to A. However, L is not connected to C. So when we connect those, that's called a diagonal of my polygon. Well, we can also connect L to E. Okay? But L is already connected to P. Could I draw some other diagonals in my picture here? Yeah, P to A. E to A. And P to C. Okay? So there are several different diagonals that you can draw that are connecting any 2 vertices that are not already connected. Now, notice, do any of those diagonals go outside of my figure?
No.
No, they all stay inside of it. So if that's the case, it's considered to be convex. Now, if we look at the bottom, however, if we have a concave polygon, this is when part of a diagonal or the entire diagonal falls outside of the polygon. So for instance, Q is already connected to R, and I can connect Q to S, and we're inside. We're good. I can even connect Q to T. We're still inside. But what happens when I go to connect Q to U?
Went outside.
Yeah, it falls outside, part of it at least, right? Or when I connect Q to V, it falls completely outside. So if that happens, it's considered to be concave. Easy way to remember this is it looks like one of the sides has caved in. That's how you can tell. So it looks like the side here, Q, W, and V, has caved in. So that's how I always remember the difference between concave and convex. Alright, so first one, everybody, what is it? Convex. It should be convex. If I draw in my diagonals, they're completely contained within my figure. Okay? What about the second one? Concave. If I draw my diagonal that goes from these 2 vertices, then they are completely outside of the figure. You can also say that the right side of that figure has caved in. So that one's concave. What about the last one? Now this one might be a little tricky because you see that point out to the side and you think, well, it's convex. However, if I try to connect this top vertice to that point, that diagonal falls completely outside my line, so therefore it is concave as well. Alright, so here are all your classifications by the number of sides. So for 3, triangle. 4, quadrilateral. 5, pentagon. 6, hexagon. 7, heptagon. 8, octagon. 9, nonagon. 10, decagon. And 12, dodecagon. And anything else would just be the n-gon. So for instance, if we had a 15-sided figure, then it would be called a 15agon. Okay? A 20-sided figure doesn't have a specific name. You would either say a 20-sided figure or a 20agon. Just kind of a generic way for any other number that's not represented here. So just like what we found by looking at our little activity, every time we drew in those diagonals, it created 2 less triangles than the number of sides. So the formula we came up with is we can take the number of sides and take away 2 from that. That would give us our number of triangles, and then we knew that each triangle was 180 degrees, so times that by 180 degrees. So this will give me my angle sum for any polygon. For any polygon. So example 2 says, let n equal 90. Find the interior angle sum of the polygon. Okay? Well, we can use our formula that we just discovered, n minus 2 times 180. So now what?
90 minus 2.
90 minus 2 times 180. So 90 minus 2 is 88 times 180. And what do I get? 15,840. So any 90-sided figure, and that would be huge, okay? Any 90-sided figure would have to measure all 90 of its angles together, would measure 15,840. So in example 3, it's wanting me to figure out the value of the variable, which in this case is y. What type of polygon is this? Pentagon, because it has 5 sides. So this is a pentagon, okay? Well, I know some of the angle measures here. I obviously don't know the angle that is represented by y. Are any ideas on how I could figure this one out? Good. We've got 3 90-degree angles.
And you have 5 sides, so you have 3 triangles.
Good. I need to figure out how much all 5 of those angles need to add. So since we had 5 sides, we knew that meant that I had 3 triangles. So let's figure that out really quickly. We can use our formula, 5 minus 2, which is going to give me 3, times 180. What does that give me?
540.
Okay, so 540 degrees. So for every single triangle, or for every single pentagon rather, they're going to measure 540 degrees, okay? So I know this is a pentagon, so therefore all 5 of those angles have to add to 540. So now what can I do?
You know that 3 will equal 90, so you can add those and 55 and subtract that from 540.
Good.
That makes sense.
I know for the angles. I've got 3 right angles. That's what those boxes are representing. I also have an angle that's measuring 135. So the only angle I do not know is my angle represented by y. But I know that all 5 of those have to add together to equal 540. So let's set that up. So you're going to have 90 plus 135 plus another 90 plus 90 plus y, and that has to equal 540. So to solve here, I need to add all that together.
I got
That would be doing the exact same thing. What'd you get, Becca?
425.
I don't think it's 425.
135. 400.
I think it gives you 405,
Is that
I believe.
135?
Yeah, it's
Oh,
130.
Yeah.
I did 155.
Yeah, it's 135. You should get 405 plus y equals 540 now. So now what?
That $100 check or junk.
Then we would subtract 400.
Good. Subtract 405 from both sides, which gives me,
Move your head.
Y equals 300 or 130.
good, y is 135 degrees. So this angle will have to be 135 degrees. Okay. So what's the first thing I'm going to have to do on this one?
How many triangles are on?
Yeah, we got to figure out its angle sum, okay? So use our formula. N minus 2 times 180. So how many sides do I have here? 6, which is going to give me 4 triangles. You're right. So 4 times 180. So 720 degrees. So all 6 angles of this hexagon must add to 720 degrees. All right, now what?
You
Add them all together, set them equal to 720. So V plus 6 plus 135 plus 62 plus 151 plus 140 equals, I'm running out of room there, 720. So those are going to go together to give me 2V. And then here, yes, I can put the 6 with all of those. 6 is just a number. It's a constant. So it goes with the rest of them. And we got 494. Now what?
So it equals to 720.
Yep,
Would you solve it like an equation?
Yes.
exactly.
So you subtract 490.
Subtract 494 from both sides. So 2V is equal to, I think it gives me 226.
Yeah.
It's 226.
Divide that by 2 to solve. V is
113.
113 degrees. Now, could I easily figure out what the angles would have to measure then?
Hey,
All you do
1300.
Yeah, plug it in. So V obviously is just going to be 113. What would my V plus 6 angle be? 119. Good. Now, if we're talking about exterior angles, they're on the outside of my figure, okay? So if I have an exterior angle, 1 at each vertex, okay? 1 at each vertex. Does not matter how many sides I have, whether I have 5 sides, 15 sides, or 50 sides. All of the exterior angles must add to 360 degrees.
So the whole polygon has to be?
The exterior angles. The exterior angles. So if you look at your picture up here, we've drawn in those exterior angles, and basically to get those exterior angles, you're just extending out the sides, okay? So you've got 5, if it's 5-sided, you're going to have 5 exterior angles. All 5 of those angles have to add to 360. If it is 15-sided, you're going to have 15 exterior angles, and they're all going to have to add to what? 360, okay? So interior angle sum changes depending on how many sides you've got. To figure it out, n minus 2 times 180. But if we're talking exterior angles, always, no matter how many sides, we'll add to 360. So in our last example here, we want to figure out what x is. So any ideas?
So what do you want? Add them all together and
You got it. Add them all together, set them equal to 360. So you've got x plus 2x plus 3x plus 4x has to equal 360. Good, we've got 10x's total when I put all those together. And that has to equal 360, so what is x? 36. True or false, each one of those angles would have to be 90. False. First of all, if they were all 90, they would all have to be congruent. And are they all congruent? No. If x is a single number and I've got an x and then I'm doubling it, tripling it, and quadrupling it, then it cannot be, they cannot all be congruent to each other. Now, if I knew that they were all the same, if it had told me that, then I would know that they would all have to be 90. But they're not all the same, so each angle will be different with x being 36.